Before we move on to our next overclocking strategy, I would like to discuss the Prime95 stability test results. I already mentioned it a couple of times during this video, but this is the third time that I'm overclocking a 64-core Ryzen Threadripper. I overclocked the Zen 2 3990X, the Zen 3 5990X, and now the Zen 4 7980X. And I think it's worth bringing together all of these Prime95 data points and see how AMD has evolved in providing us with more compute power.
The comparison rules are straightforward. I take the results from each overclocking guide with the most tuned PBO strategy. For each of these three platforms, it means unlocking the power limits and letting the CPU run until it's limited by the TJ max, which is 95 degrees Celsius for each CPU. Then we compare the average CPU core effective clock frequency during a 30-minute Prime95 workload. We compare two scenarios: Prime95 Small FFTs with AVX2 and SMT enabled, and Prime95 Small FFTs with AVX and SMT disabled.
Note that this is not a one-to-one, absolutely fair comparison. The cooling mechanisms have changed throughout my overclocking guides, and I didn't retest any of the systems specifically for this comparison. So take it for what it is.
If we look at the frequency in the heaviest workload, Prime95 Small FFTs with AVX2 and SMT enabled, then the frequency improvement is remarkable. With the Zen 2 64-core, we could run almost 3.3 GHz. With the Zen 3, slightly over 3.8 GHz, and with the Zen 4 chip, we can almost run 4.6 GHz. That's 1.3 GHz more than Zen 2 and 800 MHz more than Zen 3. If we look at the frequency in a more moderate workload, Prime95 Small FFTs with AVX and SMT disabled, then the frequency improvement is still impressive. With the Zen 2 64-core, we could run at almost 3.9 GHz. With Zen 3, slightly over 4 GHz. But with the Zen 4 chip, we can run a little over 4.9 GHz. That's about a 1 GHz improvement.
This frequency improvement is a combination of many factors.
The first significant contributor is improvements in the manufacturing process, which shift the voltage frequency curve in favor of higher frequencies at a given voltage. We can see this very well with the Ryzen Threadripper. In the heavy Prime95 workloads, the optimum voltage stays the same even though the Zen 4 7980X, built on TSMC 5N, runs at significantly higher frequencies. A second major contributor is the ability to deliver substantial power to the CPU cores. I know it's popular nowadays to comment negatively on CPUs with high power consumption. Still, from a business perspective, using slightly more power on one CPU to meet a particular performance target is better than having to use multiple CPUs and multiple motherboards. So, CPU and platform engineers must figure out how to reliably deliver such high power to the CPU. As we can see from the data, the Zen 4 Ryzen Threadripper can push substantially more power through the 8 CPU chiplets. That's mostly down to the VRM, I suspect. The voltage of the CPU cores is provided by not one, but two VDDCR CPU voltage rails. This is a significant change from previous Ryzen Threadripper platforms. The main advantage of adding an extra voltage plane is that it's much less taxing on the VRM. In case you missed my SkatterBencher number 43 overclocking guide with the Ryzen Threadripper 5990X, a key limiting issue for reaching maximum performance on the previous gen was that under overclocked conditions, the EDC or electrical design current would peak over 800 amps. That would trigger the VRM OCP and shut down the system. The current draw is now split between two power planes. The current draw per power plane also halves. So as a result, there's no more VRM limitation when overclocking, not even when you push all 64 cores to their limit.